Hello, hello. We are talking about the end behaviors of polynomial functions today. End behavior is referring to what happens to the extreme ends of a function. So I'm just going to start off with this example of f of x equals x squared. So we should know what that parabola looks like. It opens up. And when we're talking about those end behaviors, we're talking about where the arrows are going. So I'm going to write out this sentence. This is how we're going to describe our end behaviors. As x approaches negative infinity is just talking about as my x values are going to the left side of my graph. And it's going to look like this weird notation, x, arrow to the right, negative infinity. That means as x approaches negative infinity. So negative infinity is on the left side of my graph. My parabola is pointing up and to the left. So as x approaches negative infinity, y is approaching positive infinity. That basically just means as x goes left, y goes up. So we also need to talk about the right side of our graph. So we'll read this part as x approaches positive infinity. It's just talking about as my graph moves towards the right side, what is my y doing? It's going up towards positive infinity. So this means as x approaches positive infinity, y approaches positive infinity. So because both of these y values are approaching positive infinity, we say that they have the same end behavior because the left side is going towards positive infinity and the right side is going towards positive infinity. So when you are asked to describe the end behavior, what I'm highlighting is your answer. Let's try to describe the end behavior for f of x equals negative x squared. So I'm just going to sketch the graph of this parabola. Remember that negative in the front tells us that this parabola is pointing down. So I can describe this as x is approaching negative infinity, or as x goes to the left, y is approaching negative infinity as well. So as x goes left, y goes down. So that first one's describing the left side of the graph. Now I need to describe the right side of the graph. So as x goes towards the right, or as x approaches positive infinity, y approaches negative infinity as well, because as that graph heads towards the right, the y values are pointing down towards negative infinity. These also have the same end behavior because they're both pointing down towards negative infinity. Again, what I'm highlighting is how you describe the end behavior. It's a lot easier to describe end behavior for functions that we don't know if we take a look at what those functions look like on a graph. If you don't have a graphing calculator, you could do the same exact thing by plugging in some negative x values, 0, and some positive x values, making a t-table and creating a graph for x cubed. So this is what x cubed looks like in my graphing calculator. So I'm just going to sketch that graph onto my paper. So really, we're trying to learn how to speak math. As x approaches negative infinity, or as my graph is going towards the left, I'm trying to analyze what those y values are doing. I can see on the graph that they're going down, and I can see on my table in my calculator, those y values just keep getting farther and farther away from 0 in that negative direction. So I can say here, as x approaches negative infinity, y approaches negative infinity. Or if we translate that to English, as x goes left, y goes down. If we look at the x values towards the right, or if we're looking at as x approaches positive infinity, our y values are going up. Those y values keep getting bigger and bigger and bigger in the positive direction. So as x approaches positive infinity, y approaches positive infinity. Now, because our y's go to two different locations, one goes down to negative infinity, one goes up towards positive infinity, we say that these have opposite end behaviors or different end behaviors. Let's look at what happens when we have f of x equals negative x cubed. I'm going to put this into my graphing calculator. If you do not have a graphing calculator, then you are stuck choosing some negative x values, 0, and some positive x values, making a t-table, and then graphing this by hand. But with this graphing calculator, I can save myself some time, and I can just take a look at the sketch of this graph, and I can predict what those end behaviors are going to be. So here, as x approaches negative infinity means as I'm going towards the left, what is y doing? It's going up, so it's going towards positive infinity. And then as I approach the right side, or as my x approaches positive infinity, the y's here approach negative infinity. So the end behaviors are still different, or they're still opposite end behaviors, because one side is headed towards positive infinity and the other side is headed towards negative infinity. In English, you could think as the graph goes left, the y's go up. As the graph goes right, the y's go down. So as an inquisitive mathematician, we're going to try to look for a pattern here. So we want to describe the end behaviors for all four of these functions. So first I'm going to look at x to the fourth. I want to describe as x approaches negative infinity, what does y approach? Or as x goes left, where does y go? As x approaches positive infinity, I want to think as x goes to the right, what does y do? So in my calculator, I've typed in x to the fourth into my y equals. I want to see what this looks like on a graph. I can see that it looks sort of like a parabola, but maybe like a little wider, a little fatter. I can see that those y values are getting really big, really fast on the right side. And they're also getting really big, really fast on the left side. So I could describe this end behavior as they're both going towards positive infinity. When I take a look at negative x to the fourth, I can see that both sides of that graph is going towards negative infinity. So it looks like an upside down parabola, but maybe a little fatter or a little wider. And I can see on my t-table that those values are getting smaller and smaller in the negative direction on both sides of my graph. When I look at x to the fifth, I can see in the graph that as x approaches negative infinity, y approaches negative infinity as well. Or as x goes left, y goes down. And as x approaches positive infinity, y also approaches positive infinity. Or as x goes to the right, y goes up. And then notice here I can also look at my t-table to give me a little bit more confidence that I'm writing that end behavior correctly. As we look at the last example, negative x to the fifth, I can see that that looks just like my negative x to the third, except maybe it's a little fatter. And I can see that on the left side, my y's are going up towards positive infinity. And I can see that the right side, my y's are going down towards negative infinity. So we should see a pattern here. We should see that both of these x to the fourths have same end behavior, and that both of these x to the fifths have opposite end behaviors. It's not a coincidence that the x squared and the x to the fourth functions all have same end behaviors. It is also not a coincidence that the x cubed functions and the x to the fifth functions have opposite end behaviors. We're going to go ahead and make a rule for these on the next page. So here's your rule or your cheat code for our end behaviors. If you have a function with an even degree, so x to the second, x to the fourth, x to the sixth, any x to an even number power, those are going to have the same end behaviors. And if you have a function that has an odd degree, x cubed, x to the fifth, x to the seventh, they're going to have opposite end behaviors. We also need to pay attention to the leading coefficient, or the number in front of that term that has the highest degree. If we have a positive leading coefficient and an even degree, that means that both of those end behaviors are going to point towards positive infinity. And if we have a negative leading coefficient and an even degree, both of those end behaviors are going to be pointing down towards negative infinity. We can still pay attention to those leading coefficients for odd degrees. If your leading coefficient is positive and you have an odd degree, that means that on the left side, it's going down towards negative infinity, and on the right side, those y values are going up towards positive infinity. If you have a negative leading coefficient and you have an odd degree, then it's just going to flip around. The left side's going to go up and the right side is going to go down. Keep in mind that all we're talking about for these polynomials are the arrows. What are the arrows doing at the ends of the graph? So when we describe these end behaviors, you are paying attention to what degree you have and what the leading coefficient is. That's all we're looking at. Take some time here to pause the video and try to describe the end behaviors. So I have these set up for us as x approaches negative infinity, y approaches what? As x approaches positive infinity, y approaches what? And I've done that for both examples. So I know that this first one is an odd degree, so I'm paying attention to this odd degree. I can see that it's got a positive 1 as a leading coefficient, so then I know it's going to go down to negative infinity on the left, and it's going to go up to positive infinity on the right. When I look at the B example, I see that it's got an even degree, so I know it's got same end behavior. And I know that the leading coefficient is negative 1. So I know that both of these are going to point down towards negative infinity. If you don't believe me, let's go ahead and plug these into our graphing calculator and we can look. So I typed in this first equation, exactly how I saw it on my paper, into my graphing calculator. You can see that this looks really funky, but you can see that the left side is pointing down and the right side is pointing up. So our predictions were accurate. If I plug in this second example, you'll see that we're also correct for these predictions of our end behavior. I'm typing in this function exactly how I see it on my paper, and then I'm going to go ahead and look at the graph. When this graphs, we'll be able to see that the left side is pointing down and the right side is pointing down. These functions look pretty cool. That's it for today, guys. We'll see you next time. Thanks for coming. Hope you learned.